Let's look at the problem 2 of exercise 7c. In a class of 20 students, 12 study biology, 15 study history, and 2 students study neither biology nor history. So before we go into the questions, let's record the information that was given to us. We're constructing a Venn diagram, okay? So one circle for biology, another circle for history, okay? They gave us 2 subjects. Sometimes you will have 3 of those bubbles, 3 circles, but in this case, there are only 2 subjects. Okay, they're overlapping. Why? Because there will be students that study both biology and history. Okay, so biology equals 12 students. I have a habit writing it outside of the circle, appropriate circle. Why? Because writing it inside can be misleading later. Why? Because we have this part of the circle, like a crescent of the moon, okay, that's students that study biology only. And that part where there's biology and history studying students, and similarly here as well, so history only or history but also biology. So I recorded outside. So biology 12 students, history 15 students. Now we're usually on the bottom right corner, we are recording students that, or the information that is neither nor. So it's just, they're not doing either biology or history. That's 2 students. And of course, last but not the least, U, sample space. Sample space meaning all of it, all together, the total number of students in this case. So it's 20. Good, so we've recorded everything that was given to us. Now we can go into the question. Find the probability that a student selected at random from this class studies both biology and history. So they want the probability of this part, don't they? This middle part. Well, before we find the probability of that middle part, we need to find, obviously, how many people actually are there that study both subjects. Well, we don't know, therefore, we will assign an x to it. X. We don't know, we'll try to find it. Look, if the middle part is x and biology altogether is 12, the full circle, well, what is then that part, biology only? 12 minus x. Now, if that's full history and some of it is x, therefore history only is 15 minus x. Well, it seems like we have a lot of x's. What do we do with that information? Now we can construct a very nice equation. Why? Because if we basically add up the number of students, which we don't know yet, but we will find in a moment, okay? Number of students that study biology only, plus history only, plus the number of students that study both biology and history, plus the ones that study neither, wouldn't it equal to 20 students altogether? Yes, it would. So we're just basically adding the parts together. That plus that plus that plus this equals 20. That's exactly what we will do. So answering sub-question A, 12 minus x plus middle part x plus 15 minus x plus the ones that don't study either of these 2 subjects altogether must be 20. Must be 20. Now we can safely remove the brackets now. Why? Because there are no negatives before them, so it's all pluses. Remember, if you had a negative here or negative before this bracket, as always, it's just a reminder, you will need to distribute that minus into each term inside the brackets. Or if it were here, again, you have to multiply that minus, because essentially it's minus 1. Minus 1 into each of those. But we have all positives before the brackets, so we can just get rid of the brackets. So let's rewrite. Good. Now we need to collect the like terms. Well, we have 2 types of like terms here. Numbers or those x's. They're all simple x's to the first power, so we can add them and subtract them. Right, what do we have? We have a number here, so positive 12, positive 15, positive 2. When we add them up together, what is it? 29, isn't it? 29. Well, we have negative x, positive x, negative x. These are also like terms. Well, this negative x and that positive x, basically they cancel each other out. So we have minus x left, and that equals 20. Now, remember, we need to solve for x. We're not interested in 25 minus x. We're not even interested in negative x. We want x only, just that part. Well, it's on the left side of the equation. Therefore, you need to consecutively get rid of anything that surrounds it. Yeah? Okay? It can be one-step equation, two-step, three-step, four-step equation solutions, all right? However many steps it takes to get rid of everything else on the left side of this equation and be left with x only. We need to isolate it. Well, let's get rid of 29 first. Well, it's a positive 29. So I'm going to subtract 29 here because, therefore, look, 29 minus 29 gives us a 0. Right, but then we will have to remember that we can do whatever we want to one side of any equation. We can multiply, divide, take a square root, whatever you want. But we have to do exactly the same thing to the other side of the equation to make it fair, so that we don't break the equality. So minus 29, therefore, on this side as well. What have we got left? It's not x yet. It's a minus x, a negative x. Why? Because the positives and negatives, they belong to the number of variable that comes after it. They're together. It's not just x, it's actually a negative number. Negative x equals, well, 20 minus 29 is minus 9. Now, what you can do, you can either multiply both sides by this negative. Why? I want to get rid of this negative sign. Essentially, this negative is the same thing as negative kind of 1 times x. That's what it means, really. It's negative 1 times positive x. So I want to get rid of this minus. I don't want to see it there. So I can either multiply or divide both sides by this negative 1. So let's say I'm multiplying by minus 1. Here, therefore, I also have to multiply by minus 1. Okay? I'm going to now erase that so it's not confusing anyone. So therefore, negative times negative gives us always positive. So we achieved our goal here. It's x. So negative 9 times negative 1, again, negative times negative gives us positive. X equals 9. Now, what happened? Yay, we found that 9 students study both biology and history. So I'm going to go ahead and erase this x in the middle, and I'm going to put 9 in there. Well, 12 minus x, 12 minus 9. What does it give us? It gives us 3. So erase that. That's 3. Remember that I said at the beginning that I don't like writing 12 inside a circle. Well, look at this. This is 3, this is 9. It's the full circle that is 12. All right, here, again, 15 minus 9. 15 minus 9 gives us 6. Okay. Good. Now, is this the answer to your sub-question A? Not quite, because they're asking for the probability of that. Probability of these students. So you're picking out a person randomly from the crowd of 20 students, and what's the probability that student actually studies both subjects? Well, now that we know the number of students, it's much easier. We will say that the probability of biology and history, so that sign is for and, so both, okay, what does it equal to? Well, it's 9 students out of how many? Out of 20 students, okay, and that is your answer. Now let's go into B. What is it asking us in B? Given that a randomly selected student studies biology, find the probability that that student also studies history. So this sub-question B is about conditional probability. Conditional probability. So I'm going to go into sub-question B. What does it mean, conditional probability? Okay, look, conditional probability means that you are looking at this that way. First, there is one event happening, and then out of that event that already happened, what is the probability that another event is happening? Okay, so they're saying that given that a randomly selected student studies biology, so this is it, this is your first event, given that it's a biology student, so it's in this circle, right? Nothing else matters anymore. That part does not matter, this part does not matter, that part doesn't matter anymore. In conditional probability, always look at the one that happened first and then concentrate just on it. Imagine that it's a separate question, separate task, right? So they said that given that the randomly selected student studies biology, bam, that's it. The focus is only on the biology bubble, circle. Nothing else matters now. Find the probability that this student also studies history. Well, if I'm looking at this only, altogether there are 12 students. How many within that also study history? Well, 9. But this time it's not 9 out of 20. This is 9 out of the biology students. So it's 9 out of 12. So I will record it like that. Probability of history, but given that biology already happened. Okay, this might look a little bit confusing sometimes. Please concentrate here and remember that biology, the second letter, the second event that will be written in the conditional probability brackets is always the first event. So this is the first main event. This is the first one. And then given that, what's the probability that this is also the case? Okay. So given that this already happened, biology, what's the probability that that student also studies history? So it's this part. So it's 9 out of biology, right? 9 out of 12. We can simplify now, okay? Because both numbers are divisible by 3. So 9 divided by 3 is 3. 12 divided by 3 is 4. And that's your answer. Okay, and last, C. In an experiment, a student is selected at random from this class, and the student's course choices are noted. If the experiment is repeated 60 times, find the expected number of times a student who studies both biology and history is chosen. So let's just concentrate first on the second part of that sub-question. Find the expected number of times a student who studies both biology and history. Again, so I'm going to remove that. We don't need this green one anymore. So again, we're back talking about the whole thing, right? Everything. All right, well, look, what's the probability that a student chosen at random from this crowd of 20 students is studying both biology and history? We already know that. We found it actually. Biology and history, 9 out of 20. That's out of everyone. Okay? Therefore, what we will say that so the probability, let's just record it. Probability of B and H is 9 over 20. What else they're saying? They're saying that they repeated that experiment how many times? 60 times. So 60 times. So this is a probability for one event. For one. Why? I'm saying if I pull out one student from the 20 students, what's the probability he or she will be studying both biology and history? For one event is 9 in 20, 9 over 20. But what if I repeat this exact experiment 60 times? Well, what I need to do is to multiply that by 60, right? So the expected number of students studying biology and history must be 60 times the one-time probability, right? And then you can use your calculator, because you're in AI, you can use your calculator, and turns out it's 27 students. It's 27 students. Again, let's reflect on that. If you repeat your experiment 60 times, then expected, again, you might end up with a different number, 26 or 28, give or take. But the expected number of students that you might end up with, and likely to end up with, very likely to end up with, is 27 or around 27. So we call it expected probability. Okay, so it's not experimental probability. This is expected. Generally, we're saying that for one event is 9 in 20, but repeated 60 times, we should end up with 27 students. And that's it for the question 2 in exercise 7C.